Hey, what's up, guys? Mr. Papanik here. We're going to work through the power series and Euler's approximation checkpoint review. We're going to work through the first problem where we're trying to write a power series that models the function f of x equals 3x minus 1 over x squared minus 1. So just remember, with every one of these power series that we've done this far, we're really looking to change whatever function it is into a form that looks a whole lot like a over 1 minus r, because that, of course, is the sum of a geometric series, right? So if we can make our function look like that, we can write a power series basically using our sum of a geometric series, right? So if we're starting out with f of x being equal to 3x minus 1 over x squared minus 1, this thing is super funky, right? There's not one term on top. We can't call that whole thing a. Writing it as 1 minus, not a big deal. It's just the top that's really a problem, right? So we're going to use partial fraction decomposition to kind of simplify this for us. So we're going to start out with our 3x minus 1 over x squared minus 1. Of course, that's equal to a over x plus 1 plus b over x minus 1, right? Each of these denominators came from this denominator factored out, right? So all we need to do then is clear out those denominators, right? So we're going to multiply by x squared minus 1. Of course, on the left-hand side, you're left with just 3x minus 1. On the right-hand side, we'll have the factor that is in the denominator left on top, right? So you'll have x minus 1 times a plus x plus 1 times b, right? And so then we have to choose values of x so that one of these terms goes away and we can quickly and easily solve for a and b. So I'm going to first let x equal 1, and that's going to get rid of the term with a in it, right? So when x is 1, 3 times 1 is 3, minus 1 is 2. So you get 2 equals, this whole term goes away. 1 plus 1 is 2, so you get 2 equals 2b. Of course, that implies that b is 1. Right? Next thing we're going to do is let x equal negative 1. Of course, that's so that this term with b goes away. Right? So 3 times negative 1 is negative 3. Negative 3 minus 1 is negative 4. And then, of course, negative 1 minus 1 is negative 2. And that, of course, implies that a is 2. Right? So we've just rewritten f of x so that we have 2 over x plus 1 plus 1 over x minus 1. Right? These look a whole lot nicer. Here we've got an a of 2. R is unclear still. A little algebraic manipulation will clean that up. Here a is 1. Again, a little algebraic manipulation is going to clean that up as well. Right? So right now we're gonna kind of just rearrange some things. 2 over 1 plus x plus, I'm going to do 1 over negative 1 plus x. Okay, this should be pretty clear. 2 over 1 minus negative x. We've seen stuff just like that before. This one, I'm going to factor out a negative 1, which would make this the opposite of 1 minus x. I'm going to put that opposite up top just to make it a little easier to see. And now you've got an a and an r for each of these parts, right? So I can actually rewrite this one, the one on the left, as the sum, as n goes from 0 to infinity, of a, which is 2, times our r value, right, which is negative x. We're going to raise that to the n. The next one, similar idea here. You're going from n to infinity, or from 0 to infinity. A is negative 1. Your r value is just plain old x. And really all we have to do now, we can kind of clean up each of them. There's no sense in really putting them together right now. Even if we're looking for the interval of convergence, we're more likely to find that in an easier way by just looking at the convergence of each independently and then working from there. So for tomorrow, really, all I'm looking for you to be able to do is write out both of these parts, right? I should have taken that one out, right? Because really, I'm just trying to write this nicely and neatly. So we're going to put that -1 outside, and then we'll just have x to the n, right? Guys, I hope this helped. Don't forget to like and subscribe.